Hi guys, I hope you're good, I hope you're well and excited for our lesson today. We are still working with exponents, but now we've taken a small turn into said expressions. So it's still the same thing, but in a different representation. So said expressions of today will be looking specifically at multiplication and division, right? So bring that pen and paper and let's see what we have for today. So, as we've previously discussed, that the laws of exponents can also be extended to include rational numbers. So we can extend the laws of exponents to include rational numbers. So as we define the rational number, what a rational number is, so rational number is any number that can be written as a fraction with an integer in the numerator and also the denominator. So a rational number is just a number that can be written in the form of a over b, where both a and b are integers. So in this lesson, we'll look at simplifying said expressions under multiplication and or division. So there will be a mixture of either multiplication and division in one question, or just multiplication or just division. So here you have the laws that we use. So these are the additional laws that we use to simplify said expressions. So the first rule says, if you have the nth root of a multiplying by the nth root of b, you can simply say that is the nth root of a times b. So if I explain this in normal terminologies, I will say if I have the square root of 4 multiplying the square root of 2, for example, this simply means I can take one square root and say this is 4 times 2, and I just get the square root of 8. And the second rule says, if you have nth root of a fraction, so the nth root of a fraction now, it means you can easily distribute that nth root into each part of the fraction. So it means here we can distribute the nth root into each part of the fraction. So let me just simplify this and use different values. So if I have, let's say, the square root of, let me choose good numbers, of 4 over 16, for example, it means I can write this as the square root of 4 divided by the square root of 16. So as long as the number or the value of n is the same. So as you can see here, I've been using the value of n to be 2, 2, 2 all the time. So if the value of n is the same, this is the rule that applies. So if you have one huge square root there, just know you can easily distribute that square root into both values. The third law says, if you have two root signs or two radicals following each other, you can easily multiply their values there. So if I have the square root of, for example, okay, let me just use the cube root and also just a square root of 4, for example. It simply means I can just say this is one root, but of 3 times 2, so this will be the 6th root of 4. So you just simply multiply what these two values mean. And as you go, we have one more rule that says, if I have the nth root of a to the power of m, I can simply write that as a fraction. So as we need to understand that the radical sign alone simply means you have a fraction. So if I give you one example, I will say if I have the square root the square root of 2 to the power of 3 can be written as 2 to the power of 3 over 2. So this is just a breakdown of the fact that this is 1 over 2 times 3. So you can write this in that format. And the last rule that we need to understand for the day is that it's actually similar to the one that we are coming from, but it simply says if you have a huge bracket, so now you have a bracket for both the radical sign and also the value of a, so and if you have m there as a power, it will apply the same thing shall apply. So it means if you have, let me just use different numbers instead of 2. So if you have the cube root, just say the cube root of 3, but this now is to the power of 2, you simply have your answer as 3 to the power of 1 over 3 times 2. That is why your answer will be 3 to the power of 2 over 3. So guys, that is how you break down each law, what each law means. So I've used the normal symbols that they use, but I've given you also numbers on the side so that you can understand if we use actual numbers, how easy this rule is. So you're using this as an interpretation actually. So you can write this down on your notes so that I can keep them safe. That will be actually amazing. Now, on the real deal now, you have the one beautiful example. Say simplify the expression without using a calculator. So you need to simplify the square root of 2 to the power of 5, which is multiplied by the square root of 2 to the power of 0, divided by the fourth root of 2 to the power of negative 6. So things are getting interesting here, and let's see how we can easily get answers. So remember, it says negative there, so you still bring back that negative. And the top part, we are going to look at the rule that says if you multiply two values like that, you can just simply use one square root sign and say this is a times b. So since you can see you have 2 there and 2 there, it means you have the same thing. Now you can easily say I can take one square root sign and say this is 2 to the power of 5, 2 to the power of 5 times 2 to the power of 0. And you divide this, you can divide this by saying now on the other side I have the fourth root of a negative value. So you have two ways of doing this. So you can easily use the law now to break it down, or you can simplify the value and try to break it down later. So now let's try to do it the easy way. So now you will have to say this is the square root. Actually just remove the square root, you don't have to use it anymore. So you can say this is 2 to the power of negative 6, but multiplied by 1 over 4. Why did I choose 1 over 4? Because you have a 4 there. Now, moving from that, you have a negative. So you have a negative still 2 to the power of 5 times 1 over 2. Because 2 to the power of 0, so if you add the exponents, the bases are the same, but if you add the exponents, so you have 5 plus 0, it's still 5. So there's no point of us adding any other number because 5 plus 0 is actually 5. So the reason why I said 1 over 2 is because I removed the square root sign. And I divide this now by 2 to the power of negative 6 over 4. And if I move on again from these guys, we will find ourselves with this case here. Let me just write it on the side for you. So you'll find yourself with negative 2, 5 over 2 divided by 2 to the power of negative 6 over 4. So actually you can simplify 6 over 4 into, this is going to be 3 over 2. So we can actually now use 3 over 2. So let's just remove that. Let's use 3 over 2. So you see divided by 3 over 2. So it's a negative 3 over 2. Let me just write it so that it's actually very visible for you. So this is going to be 2 to the power of negative 3 over 2. Now, what you note from both sides, guys, is that now you have the same base. So if you have the same base, both sides, rules are simple. Same base, while you're dividing, go back to our very first lesson. The rule is there. If you are dividing, you can subtract the exponents. So you can simply take one base and subtract the exponents. So it means here you will have negative, and then you simply write, this is a 2, you take only 1, 2, and then we subtract the exponents. So 2 to the power of 5 over 2 minus, the reason for that minus is because you are dividing. So when you divide, you subtract the exponents. So this is minus a bracket of negative 3 over 2. So solving that fraction on the side, if I have 5 over 2 minus into minus 3 over 2, I will say this is 5 over 2 plus 3 over 2. The reason now it's a plus because two negatives following each other, they create a positive sign. So now this is going to be, since the denominators are the same, this is going to be 5 plus 3 over 2, which gives me which gives me 8 over 2, which is a 4. So that is why you have here negative 2 to the power of 4. So that is how you simplify this expression. So this one is quite exciting because it was a mixture of your exponents with fractions themselves. So you need to bring up your knowledge of simplifying fractions, of understanding two negative signs. So guys, there's quite a lot that you need to understand before you can actually simplify this. So please go back to this question, try to do it again and again and again. But I have one more for you, and let's see what we have. So it says simplify the expression below without using a calculator. So we shall not be using calculators at all. So good luck to us. Let's see. So it says 12m to the power of 7 over 9 all over 8m to the power of negative 11 over 9. So guys, the first thing that you do here, you look at the values, look at the numbers first. So you have 12 over 8 first. You separate it from the whole mass of those exponents. So look at 12 over 8 first, and you simplify that. So if you simplify 12 over 8, so which number goes into both of them without leaving a remainder? So we can use a 4. So 4 goes 3 times on 12, and it goes twice on 8. And then we separate this for now and just say this is m to the power of 7 over 9 minus into minus 11 over 9. So what we did there, because we have m and m both sides, so we take one m and subtract the exponents. So it's the normal laws of exponents, guys. If you are dividing, you take one value and you subtract the exponent. So you take the base and subtract the exponents. So you will have here 3 over 2 m to the power of 7 over 9 plus 11 over 9. Why is it 11? Why is it a plus actually now? Because you have two negatives there. So you have this negative and this negative there. So when you multiply them together, they give you a positive sign. Now, as you move on from that, it means you will simply have 3 over 2 m to the power of, so we look at our denominators, they're the same, so we can simply say this is 7 plus 11 divided by 9. Now you'll have 3 over 2 m to the power of 18. 7 plus 11 is 18 over 9, and this is going to be 3 over 2 m to the power of 2, because 18 divided by 9 is 2. So guys, this is how you also work around these values. It's not difficult. You just need to keep on practicing as much as you can, guys. So you keep on practicing, and trust me, you won't struggle at all with these issues. Now, the last problem that I have for you, it was just me showing you how do you actually simplify such a value. So it goes back to one of our laws of these set expressions, that if you have a square root and a square root both sides, you can simply use one huge square root and include both values there. As you can see, we have 2 and 32, and separated by the multiplication sign that was there at first. And you're going to say 32 times 2 is 64. So the square root of 64 is 8. Guys, most of these questions will always say without using a calculator. You need to know your square roots very well. Just practice them. Just start with 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. You will be able to know all your square roots, so that if you don't have to use a calculator in an exam, you will be getting the right answers either way. So guys, thank you for joining me on today's lesson on simplifying set expressions using multiplication and division. And guys, I'll definitely see you on the next one.